In this video, we will learn how to find intersection points between grid lines and how to label them by their grid names. This script is especially useful when you need to tag elements in a way that clearly ties them to their location. For instance, a beam labeled B01, A1, A2 might represent the first beam on level 01, positioned between grid lines A1 and A2, making it easy to identify, reference, or locate in both documentation and on-site coordination. The graph begins with a Select Model Elements node that lets you manually choose all the grid lines in the Revit view. These grids are passed into two key nodes. Grid.Curve extracts the geometric curves from the grid elements. Remember, Element.Curves does not work on grids. In this case, we're working with 14 grids. Keep this number in mind while we're progressing with the script. Element name retrieves the grid names for labeling. Geometry.IntersectAll takes the grid curves and computes all pairwise intersections. It's wired in a way that tests every curve against all others using cross-product lacing. Leaving the lacing to shortest, you'd only compare items in matching list positions, missing many intersections. Cross-product gives us the full grid of combinations automatically. The output is processed through list.isEmpty to determine which intersections exist. Empty lists equals no intersection. List flatten cleans the nested list structure for downstream clarity. The output from IntersectAll is deeply nested. Each grid compares to all others, and each result is a sublist. We apply flatten to reduce this, and we use longest lacing so that we flatten the content of each sublist. In doing so, we remove all nested lists and empty values. We then have a list of intersection points and one line, the result of the grid intersecting itself. Try to change lacing to shortest or cross product and see the difference. List.filter by bool mask. Using levels, at 2, we can assign the Boolean mask coming from list is empty to our list of grid names and obtain 14 lists of grid names that intersect each other's. Setting the correct level is crucial. It tells Dynamo how deep in the nested structure to apply the filter. That keeps the geometry and names correctly filtered together. Let's now combine our initial list of 14 grids with the results of the intersection points and the grid names. Index of finds where filtered grid names appear in the filter by bool mask output. List.removeItemAtIndex uses to remove the self-intersecting grids, appearing as lines instead of points, from the intersection results. SetDifference is used to remove the initial grid name from the filtered list of intersecting grids. The plus node is used to combine the grid names for each intersection point. Document, current, and document.ActiveView are fetched to place text annotations in the correct Revit view. Finally, TextNote.ByLocation places a note at each intersection point. It takes as inputs the corresponding grid names after string manipulation, the current view context, a given text note type and font size,